Hello, and welcome to G Fun Facts Online. Today we're diving into an invisible force that flows through our cities, stadiums, and festival grounds. It's a force that can be incredibly festive and unifying, but one that can also turn deadly in a heartbeat. This force is the crowd, and the science of understanding its every move is called crowd dynamics. From the pure joy of a World Cup celebration to the utter tragedy of a crowd crush, the principles of crowd dynamics are always at play, governing the ebb and flow of humanity whenever we gather in large numbers. The study of crowd dynamics pulls from physics, computer science, psychology, and sociology to unravel the incredibly complex behavior of people in groups. It's a science that has been shaped by tragedy and refined by decades of research, all with one ultimate goal: to make sure that when we come together, we can do so safely. So today, we're going to explore this fascinating and often misunderstood world, from its historical roots to the cutting-edge technology that's making our world safer. The formal study of crowds actually began in the late 19th and early 20th centuries, a time of major social unrest in Europe. And frankly, the early thinkers were motivated by a fear of the mob. One of the most influential figures was a French physician named Gustave Le Bon. In his 1895 book, The Crowd, a study of the popular mind, he argued that when individuals join a crowd, they lose their sense of self and get swallowed by a collective mind. He believed this led to a state where rational thought is just thrown out the window in favor of instinctual and often destructive behavior. He came up with three key ideas: submergence, where you lose your sense of personal responsibility because you're anonymous; contagion, where emotions and ideas spread like a virus; and suggestion, where the crowd becomes incredibly susceptible to a charismatic leader or a powerful idea. These early theories painted the crowd as a primitive, irrational, and dangerous beast. But this view began to change around the mid-20th century. Researchers started to question if crowds were really so inherently bad. After all, they can be a force for incredible social good. This led to a more nuanced idea called de-individuation theory. It suggests that being in a crowd can lower our self-awareness and make us less concerned about what others think. This can lead to antisocial behavior, sure, but it can also create a powerful sense of unity and shared purpose. But the biggest leap forward came with something called the social identity approach. This theory is revolutionary. It proposes that our sense of self isn't just personal, it's also derived from the groups we belong to. When you're in a crowd, say at a concert for your favorite band or a protest for a cause you believe in, your shared social identity becomes incredibly strong. This has huge consequences. You start to see the world through the lens of that group's values. It allows you to coordinate your actions with thousands of other people, often without a single word being spoken. And it's empowering. Suddenly, you're not just one person. You're part of a collective capable of achieving amazing things. So from this perspective, a crowd isn't irrational. Its behavior is a meaningful expression of a shared identity. The psychology explains the why, but to understand the how, we need to turn to physics and computer science. By treating crowds as complex systems, researchers can model their movements and spot danger zones before they ever become dangerous. One of the earliest ways to model a crowd was to treat it like a fluid. Imagine a river of people flowing through a street. This fluid dynamics approach is useful for understanding large-scale movements and identifying bottlenecks, but it's limited because, well, people aren't water molecules. We make decisions. That's where a more sophisticated idea comes in, the social force model, developed by physicist Dirk Helbing. This model treats every single person as an individual agent who is influenced by different forces. There's a driving force, which pushes you towards your goal, like the exit of a train station. There are repulsive forces, which represent our natural desire to not bump into other people or walk into walls. And there can even be attractive forces, which model how people tend to form groups or get drawn to something interesting. By simulating these forces for every person, this model can predict incredibly complex crowd behaviors. It can show how distinct lanes form naturally when two crowds walk in opposite directions. It can also demonstrate the terrifying faster is slower effect, where in a panic, everyone pushing and shoving to get out of a door actually slows the evacuation down for everyone. Building on this, we now have powerful agent-based models. In these simulations, every person is an autonomous agent with their own rules. You can program them with different walking speeds, different goals, different levels of familiarity with a place. This allows architects and event planners to build virtual replicas of stadiums or concert venues and test them. Software like Legion and VisWalk let them simulate thousands of scenarios. What happens if we close this exit? What's the best way to guide people to the train platforms? They can find the flaws in a design before a single person ever sets foot in it. Tragically, many of our most important advances in crowd science have come after terrible disasters. These events are brutal reminders of what happens when the dynamics of a crowd are ignored. On April 15, 1989, a horrific crowd crush occurred at Hillsborough Stadium in Sheffield, England. The disaster, which took the lives of 96 Liverpool fans, was caused by a perfect storm of poor crowd management, a lack of communication, and a stadium design that was dangerously outdated. A decision to open an exit gate to relieve pressure outside the stadium led to a surge of fans into pens that were already full beyond capacity. The Hillsborough disaster became a watershed moment for stadium safety worldwide. The official report led to massive changes, including the move to all-seater stadiums for top-tier matches, fundamentally changing the design to prioritize safety. More recently, in 2010, the Love Parade Music Festival in Duisburg, Germany, ended in tragedy. 21 people died, and over 650 were injured on a single ramp that served as both the entrance and exit to the festival grounds. It was a critical design flaw, a massive bottleneck that was simply incapable of handling the hundreds of thousands of attendees. This disaster highlighted a terrifying phenomenon known as crowd turbulence, or a crowdquake. When a crowd gets this dense, the pressure can become so intense that it creates shockwaves. People are lifted off their feet and moved by the surge, and if someone falls, a domino effect begins, with people being crushed under the immense weight of the crowd. And in 2021, the Astroworld Festival in Houston, Texas, brought these dangers into the modern era. During a performance, a densely packed crowd surged towards the stage, leading to a crush that killed 10 people. Investigations pointed to inadequate security and a failure to stop the show, even as the situation became dire. But this science isn't just about learning from tragedy. It's also about celebrating incredible success. While disasters grab headlines, every day, millions of people gather safely, thanks to the application of crowd dynamics. Perhaps the greatest example of this is the Hajj, the annual Islamic pilgrimage to Mecca in Saudi Arabia. This is one of the largest mass gatherings on Earth, with millions of people from all over the world. Managing this is a monumental challenge. The Saudi authorities have developed what is widely considered a masterclass in crowd management. They use advanced technology, like surveillance cameras, drones, and mobile apps, to monitor crowd movements in real time. They have undertaken massive infrastructure projects, like the multi-level Jamarat Bridge, built specifically to handle the flow of millions of people during a single ritual. Every decision is driven by data analysis and simulation. It's a stunning example of how, with careful planning and technology, even the most complex crowds can be managed safely. The Olympic Games are another global showcase for crowd science. Organizers use sophisticated simulation software for years before the games even start. They model the flow of people through every venue, every train station, every public square, testing different strategies to identify and eliminate potential bottlenecks. So what does the future hold for crowd science? It's moving towards a world that is not just safer but more predictable. One of the biggest developments is the use of real-time data. With so many of us carrying smartphones, it's now possible to anonymously collect vast amounts of data on how people are moving through a space. This data can be fed into simulation models to create a digital twin of a crowd, a virtual, real-time replica. This would allow safety officials to see a problem developing and intervene before it becomes a crisis. Virtual reality is also becoming a powerful research tool. Scientists can immerse people in virtual crowds to study how they react in an emergency, all within a safe and controlled environment. As our world becomes more urbanized and more connected, the need to understand and manage crowds is more critical than ever. The invisible force of the crowd is powerful, both for celebration and for danger. But with the tools of science, we are learning to understand it, to respect it, and to ensure that it remains a force for good. Thanks for listening to G Fun Facts Online.